hydrogen has one proton, one electron, so it has no charge. And they said, well, this isn't a no charge hydrogen. This is a positively charged hydrogen. So how can we change this hydrogen to become a positively charged hydrogen? Well, one option would be add another proton. Wait a second. If it has two protons, it would be helium. It wouldn't be hydrogen at all. Okay, well, that idea is terrible. If we can't add protons, we can remove electrons. Well, let's see. If I remove the electron, wait, it only had one electron, which means it has no electrons. 1 minus 1 is 0, which means this entire S1 shell is empty. Well, now I do have my hydrogen ion, and it is positively charged because there's only a proton. Wait, so isn't that just a single proton? Wait, you're telling me that a positively charged hydrogen ion is just a fancy name for one proton? Yep, that's exactly what I'm saying. A positively charged hydrogen ion is, in fact, the fancy name for... that color is too similar. One proton. And if that one proton can stick to water, so if I drag a water across and go, hey buddy, how you doing? If he goes, oh, sweet ching, free ride. If the proton can do that, and any single proton can, then it gets the fun name acidic hydrogen. So if I'm walking down the street and I see a single proton, I could yell 3 things and it would turn around and say, yeah, what do you want? I could be like, hey, you, positively charged hydrogen ion. And it would turn around and be like, yeah, what do you want? Or if I was like, hey, you, single proton, I'd be like, yeah, what do you want? Leave me alone. Or if I said, hey, you, acidic hydrogen, I'd be like, yeah, what do you want? This is kind of like a, you know, in those spy movies where the guy opens up his strongbox and there's like a bunch of different passports. They all have the same picture, but they have different names. One's from like Russia, one's from the US, and one's from Italy or whatever. That's kind of what this is. This guy gets 3 names. He has 3 different passports. One is called hydrogen ion, maybe that's the Russian one. One it says 1 proton, and maybe that's the American one. And one says acidic hydrogen, maybe that's like the Italian one. But it's all just the same single proton. So there it is. A single proton could be called these 3 things. Okay, but it can only be called this with an acid. So if there's no acid around, we tend not to refer to it as acidic hydrogen. That's only kind of if there's an acid around, then it'll use that name. And oddly enough, if it's an acidic hydrogen, that means that this acid has an extra proton it can give. So the way acids work is they have an extra proton laying around called an acidic hydrogen or a single proton or a positively charged hydrogen ion. And when water floats on by, I'm enjoying my day. It's so beautiful today. The acid chucks its proton onto it and the water continues on. Now, granted, it's not water anymore. Now it's hydronium. And off it goes. Me and my new friend, proton, single proton, positively charged hydrogen ion, whatever you want to call it. But the problem is, hey, wait, does this have any acidic hydrogens anymore? No, it does not. You're just a blob. It's no longer an acid. And the reason why is to be an acid, they have to have acidic hydrogens. They have to have these single protons, these positively charged hydrogen ions. And let's say it has 2, which is called a diprotic acid. You don't need to know that. Let's say it has 2. One water kind of comes by. This acid throws one of them. Hi-ya! cling, it sticks, do. Now it's no longer water, it's now a hydronium ion. And the acid, because it still has an acidic hydrogen, now it's monoprotic. It's still an acid. But oh no, there's more water. Water comes by, acid throws its acidic hydrogen, single proton, positively charged hydrogen ion. And the second it does that, it loses its name. Because now as water goes by, water doesn't get changed. Hey, you got any acidic hydrogens for me? Huh? No, I don't. I'm not an acid anymore. What about me? How about me? You could throw a single proton on me. Your acidic hydrogen, that'd be cool. Well, I'm not an acid anymore. I ran out. So, an acid is anything that has these acidic hydrogens, but the moment they run out, they lose their name. No longer an acid, now you're just a substance. Okay, let's clean up a bit. But what does that have to do with bases? So I understand how we decide if an acid is an acid by tossing it in water, see if it has any protons to throw on. If it does, it's an acid. If it doesn't, it's not. But what if we switch over to bases? Bases are the exact opposite. When water flows by a base isn't giving because acids give specifically acidic hydrogens or single protons or positively charged hydrogen ions. That's what the acids give. Bases don't give, they take. So as the water floats by, one of these hydrogens gets ripped off, and the base eats it. Now, water is no longer water. Now it's a hydroxide ion. Because it lost one of its hydrogens, one of its single protons, it is now a hydroxide ion. Same thing here. If water, which is an oxygen, two hydrogens, comes floating down, I'm water, and a base goes, give me your positively charged hydrogen ion. Rips it. Call the cops. I'm not a water, I'm a hydroxide ion now. Call the cops. Then it gets the fun term base. And as long as it can do that, as long as waters can come by, I'm just a water. Hey, what are you doing in this neighborhood? Give me your positively charged hydrogen ion. Or single proton. I'm out of here. Should have stayed in the suburbs. What was I thinking? It gets a base. It gets the term base. But the second water goes by, and the base doesn't steal anything. The base doesn't take anything. The base goes, oh, I'm so full. I can hardly carry all these wallets that I've stolen. Then the base loses its name. And now it's just a substance. So as long as water can go by unharmed, hey, I just got paid and I got all my money in single dollar bills. They're non-sequentially numbered. Does that sound good to you? Oh, I really couldn't. I'm full up on crime. Okay. And the second water can pass by without being jumped, it loses its name base. So base is only a base if it will steal from water. So then what happens if an acid and a base get together? Well, let's say that you have an acid laying around. And remember, to be an acid, it must have acidic hydrogen or a single proton, remember acidic hydrogen, or a single proton or positively charged hydrogen ion, depending on how you want to talk about it. And the acid wants to give, because remember, what do acids do? Acids give. And what do they give? They give positively charged hydrogen ions, also known as a single proton, also known as an acidic hydrogen. And then we pour a base in. Skloop. And the acid says, I'm going to give you positive charged hydrogen ions whether you like it or not. And the base says, oh yeah? Well, give me your positively charged hydrogen ions. And the acid goes, okay, here you go. And the acid goes, I've got another one, and I'm going to give it to you. And the base says, well, you know what? You know what bases do? Bases take. And you know what we take? I'll tell you exactly what we take. We take positively charged hydrogen ions, also known as a single proton. And the acid goes, oh yeah? Well, that's what I give. So I'm going to force it on you. And the base says, yeah, well, I'm going to forcibly take it. And the second the acid has no more, it loses its name. And the second the base can't handle anymore, oh, I'm so full up on, theft, I can't do it anymore. It loses its name. And now if we pour water in, water goes, hey, feel like giving me a positively charged hydrogen ion? And the was acid, artist formerly known as acid, says, I'm sorry, I'm out. I don't have anything to give you. And it keeps flowing and goes, hey, look at me. I've got these hydrogens just hanging out. Look at that. Hey, you want it? You could just grab it. You could grab a positively charged hydrogen ion. It's right there. And base goes, oh man, I'm so full. I couldn't possibly steal another thing. And water continues by. And that means the acid is no longer acidic, the base is no longer basic, and they literally turn each other off. And that's why they're opposites. Because whatever acids give, bases take. So as long as they're kind of the similar concentrations and similar strength, and we'll talk about that stuff later, they are exactly opposites. So, ding. That's the review. Acids give positively charged hydrogen ions, bases take positively charged hydrogen ions, which are also just a single proton. Book. And if the acid gives it, it gets a fun name, acidic hydrogen. If the base takes it, it doesn't get that name. It only gets that fun name if it comes from an acid, which is kind of odd. And acids give, bases take. Okay, there you go. Happy review.